doing this, when you're doing the homework, you're like, what's the point of all this? The answer hopefully is going to come in these exercises. All right, so in number 3, the formula A equals 46C gives the floor area A in square meters that can be wired using C circuits. Solve the given formula for C. All right, so we have A equals 46C. I want to solve for C, so I divide out the 46. All right, so we'd end up with C all alone, and that would be equal to A over 46. All right, so the question would be the follow-up. I mean, you want purpose, right? If a room is 322 square meters, how many circuits are required to wire this room? So I know that C is dependent on A, and they're telling us that A is 322. So they're asking us basically to solve this equation or evaluate this equation, knowing that the A value is 322. Is it 7? Yeah. All right, so how many circuits? 7 circuits. All right, these questions involve units, so I'm looking for the proper statement of what it is we have 7 of. Sometimes it could be degrees of temperature. Sometimes it could be square units of area. A lot of different possibilities. The next one, C equals 2 pi r, relates the circumference C of a circle to its radius r. Solve this formula for r. All right, so see the general structure of these kind of questions. First ask us to do something with the formula in general terms like we have been doing. Solve for r, so what do I need to get rid of? The 2 and the pi. I would also accept everything except for r. All right, so C divided by 2 pi is what r is equivalent to. Now they're telling us the circumference is 15 inches. All right, so I want the radius when the circumference is 15 inches. It says leave your answer in terms of pi. Well, that's an answer in terms of pi. It didn't say to simplify, so you wouldn't have to. You probably wouldn't be overly interested in doing that because it would involve a decimal. You could divide 2 into 15, but you get 7.5 over pi. I mean, is that a valuable number or way of representing it? I doubt it. So this is good enough. All right. But 15 over 2 pi, what? Inches. All right, because what we did was we took the units, and the operations apply to the units also, it's just we tend not to do that. But when we do something like, I don't know, you find the area of a square. One side is 3 meters, the other side is 3 meters. If I want to find the area of a square, I would do each side squared. I'd say 3 times 3 is 9. But I'm really taking 3m times 3m. So I'm doing 3 times 3 times m times m, which gives me 9m squared. All right, so that's where the units for area are coming from. In this case, the 2 pi didn't have any units attached to it. The 15 was in inches. So my final answer would be whatever the units are for the circumference. But if I had units on the bottom, then that could impact things. Maybe they cancel out completely. Maybe it becomes something per something else, like inches per second or something along those lines. Right? So these are things that you want to keep in mind. critical thinking. So we need to think critically. How is solving a minus ab equals c for a different from all the other problems we have done? How might you solve this equation for a? All right, well, sometimes trial and error happens before you can critically think, because sometimes you look at it and say, well, I could just do what I've been doing before. I'll add ab to both sides and solve for a. But the problem with that is, and I'll write that down, so this is the wrong approach. It's an attempt, but it's not a good one. You have a minus ab equals c. I need a new stylus. Let's say you tried adding the ab to both sides. You get a equals c plus ab. That's not right. That's not a useful solution. It does not solve for a, because I have an a contained within the solution. That's like defining a word but using the word itself in its definition, right? You're never getting credit for that in an ELA class. So we want to think about some other approach that we could use. The right way. The alternative technique called the right way. So we have a, bless you, a minus ab equals c. Well, I have two a's, one here, one here. This is the result of a property. So somebody applied a property to an expression and got this as a result. You know what that property was? You think about different properties that could have been at play. Commutative property, associative property, distributive property. Distributive property. What do you think, if distributive property was used, what do you think was the expression before it was used? What was on the outside of the parentheses and what was on the inside? What do you think got distributed to each part of that expression? Assuming there was a minus sign and two parts, something on the outside got distributed to each part of an expression to give this as a result. A. Yeah, each part has an A in it, right? So that must have been what was distributed. That's all a distributive property is telling us. Now, I know you probably don't play games like poker or things like that, but I'm sure you played like a card game at some point. When you're dealing cards, you're dealing a card to each person, you're distributing the cards, everybody gets a card. Now, this is the case when you use the distributive property. It would be a case where everybody got the same card, right? So maybe you want to make sure, 4 people, each person gets an ace, right? But if you want them to be identical cards, you'd have to start mixing decks together. So that's where the analogy falls apart, right? What would I have had to multiply A by in order to get an A? 1. And what would I have to multiply A by in order to get AB? B. All right. So this is it's called a factoring technique, right? Unmultiplication is what we call factoring, and it's something that we're going to explore a lot throughout this course, and you'll explore it for the rest of your high school career. But this is the very first type of factoring, just pulling out or dividing out something that is common to each term in the factor, right? So if I had something like, let's say 2 times x plus 2. I have a common 2, right? So I can undistribute. If I want to get this expression as a result from this, I would have to multiply by this 2 by this number to get 2x. What would this number be? X. 2 by this number would have to give me a 2. 1. 1. All right. Right now we're just working on how to reason that out. Later on in the course I'll show you little tricks of the trade to help you get it quickly and easily without much thought. All right, but now we have a nice expression, A times 1 minus B equals C. Our goal was to get A alone. Ah, put my parens in the wrong place. I was in a groove. Got too excited. Right, now what do I want to get rid of? The 1 minus b. We have an entire expression that we can cancel. And you'd be left with a equals c over 1 minus b. And just out of curiosity, I won't write it, but I just want to make sure that I'm constantly reinforcing this. What would be the excluded value there in that final equation? 1, yeah, because 1 would, if b were 1, that would make that fraction undefined. It would make the final fraction over 0, and that's not what we want.